Um, so right away we see something is a little bit different. Nothing major. This one shouldn't feel too much of a burn. So what is our A value? Thanks, Willow. I agree. What's our B value? Nice job. Thanks, Willow. Thanks for keep thanks for keeping us focused. Um, and so the formula isn't going to change just because a day has passed or just because there's a number in front of x squared. The formula will always be the opposite of b divided by 2a. You have it upside down? Yeah, you should not do that. Okay. Yep. So it's definitely always going to be the opposite of b, then divided by 2a. Okay. Never change. It won't change ever. And so the opposite of b in this case is what? Yeah, it switches back to being positive 4 because the opposite of a negative is a positive. And on the bottom, we're going to do 2 times a. Again, no big deal. What's 2 times 2? 4. And so the answer to this first part is 1. And so the upshot there is that we can write on our papers now with confidence that the vertex of this graph is at the point 1 comma space. And as has been the case every time prior to this, to find the number that goes in the space, we just plug the first half back in. And I'm going to be pretty meticulous about showing my work. If you ever find yourself missing these, you might want to just ask yourself, am I showing enough work? Because sometimes that's what it comes down to. So I'm going to take the business end of the equation up here, and I'm just going to copy it down. 2 blank squared minus 4 blank plus 1. And in those blanks, I'm going to put the 1 that we worked so hard to find. So from up here, the half vertex that we know, we're going to pop in. And, I think that we're batting like 900 here. Maybe a few stragglers that don't get this yet, but we all get this almost, that the green box has to go first, right? So what is 1 squared? 1, and then what's 2 times 1? 2. Right. So the big red flag for me would be if I said, what is the first part equal? And someone said 4, that would cue me to say, oh, there's a kid that doesn't understand the order of operations multiplied before they exponentiated. So we got 2 for that. And then minus 4 times 1 is 4. And then what's 2 minus 4? And what's negative 2 plus 1? So we now have our vertex. And so prior to today, what would have happened was I would have gone to my vertex, and I'm just going to do this, and I am going to mess this up. So I wouldn't copy what I'm about to do. I'm going to do it wrong. Okay. So I'm going to go to my vertex, which is at 1, negative 1, and I'm going to put a dot. You can do that much if you want. But where I would be messing up right now would be if I just continued to do it like I did it yesterday. So like if I just left my vertex, and I'm going to zoom in a little bit more, and if I just did what we've always done, if I go out 1 and up 1, immediately I'm cooked. And so what you're going to find today is that these upshot values, I'm drawing a little arrow here for you, they're not going to be the same as they have been before. And the reasoning for that is because if there's a multiplier in front of x squared, he's the boss of what we do. So off to the side, I'm going to zoom back out because that's a little close for me. Um, I don't know where you want to add this at, but I'm going to cheat and go off to the side here. I'm going to put here a table of like what we would call like the normals. And so the normals are what we have learned over the last couple of days. Normally, if I leave my vertex and I go out 1, how far up do I go? And if I go out 2, how far up do I normally go? Nice job, everybody. And we'll just do a couple more. If I go out 3, how far up do I go? Good. And then one more. If I go out 4, I would go up 16. It's not often times when I have enough room to actually go up 16. It happens from time to time. Um, so going back then to the graph, or not the graph, but the equation, the number that I want to draw your attention to, and I am going to zoom way in on this one for you, is right here. And I'm going to put a big fat green box around it right there. So this is the first new thing for the day was that you can see finding the vertex is a little bit harder. The second new thing for the day is that that number is going to take whatever's in the green box and you're going to multiply all of the normal ups by that. going to say that again. So you're going to multiply all the normals by that. So going back out to what I wrote out here, let's consider what we deem to be normal. What we deem to be normal is what's on the board, right? But now on this particular graph, I say, wait, this isn't a normal situation. I'm not going to go up one. I'm going to go up one times two, which is two. So all of our normal ups get multiplied by that scalar in front. So normally I would go up four, right? How far up will we go? I was about to say me, but we're doing it together. Normally I'd go up nine. How far up will we go? 18. And again, we're not going to have room, but it's still, we might as well, instead of going up 16, if we had room, we'd go up 32. Got it? So you will run out of real estate quicker. North and south real estate is somewhat at a premium. And when I start trying to go up this many spaces, I quickly realize I'm out. So let's see how many we can fit on this particular one. Do you have a question? You sure? Okay. So again, we're graphing not the normal 1, 4, 9, 16, but the modified times two versions. And so when I leave my vertex, I'm going to go zoom back in again here. So we all get good eyes on it here. So when I leave my vertex and I go out one, how far up do I go? Good job. Double the normal. One is two. And when I go out two, how far up? I will go eight. Again, it's normally going to be a four, but four times two is eight. So I'm going to go out two and go up one, two, three, four, five, six, seven, and eight. It's right up there at the top. So I think it's this guy here. Did I guys get that okay? And the next one, I don't think we're going to have enough room because what would it be if I left the vertex? Um, Yeah, it would be 18, and I'm not going to have enough room. And we have the same graph. That's why I like making these, is that you're seeing the same thing I'm seeing. So from that purple vertex, we would only have enough room on this graph to go up 11 or maybe 12 if you want to do that last kind of hanger on or point. So this would be the best we could do as far as plotting points. And then you do have to try to make a graph. And I'll just warn you that the graphs, when they're tighter like this, when the Y values grow quicker, these are harder to draw. And I've been doing this a long time and I still struggle with these. The ones that are tight are the ones that you're going to find yourselves, oh God, that's hard to do. You're going to find yourselves drawing and redrawing those more than the normal ones. The skinnier they get, the harder they are to make not look terrible. The next one will be harder. Are you okay with number one there? The first one? Okay. So I'm sorry to ask stupid questions, but what's the first most obvious thing you notice about problem two? Yeah, the fraction. And it's going to get in our way quite a bit. It's going to cause us issues on two ends. So let's get to it. Step one is still going to be, I mean, what it has been, and that is to write down what A and B are, right? Okay, good. And then that's funny. That's going to be on my recording. I might have to, oh, someone was falling asleep, so I rang the bell. Someone was getting ready to nod off. What's A? 1 over 2. What's B? -2. Okay, so this is where I realize now that my little warm up earlier was a little ill-timed. We have to do a quick fifth and sixth grade lesson on fractions, and I'm going to keep this as short as I can. But we're totally doomed if we can't do this. So let me give you guys some math questions. What is 6 times 1/2? Ready, go. Some of you just know. Got the math brains, and some people just go 3. Some people would say 12. Some people would say, I have no idea. Some people would say, how do you put that in a calculator? The trick to this is you got to take the whole numbers when there's fractions around, remember, and put them over 1. And then the simplest way to do it is just 6 times 1 is 6, 1 times 2 is 2, and 6 over 2 is 3. Is that the quickest way? No. But that's kind of what our thinking needs to be, is make things into fractions and then multiply them. Here's another one for you. Go home tonight and ask your parents, mom or dad, what is 4 divided by a half? And I can almost guarantee you a lot of them are going to say 2. And it's not 2, but it's an interesting experiment. That's how the human brain works, is it hears 4 and it hears half and it says, oh, half of 4 is 2, right? You guys remember the old copy dot flop? Someone earlier said keep, change, flip, I think is the way she learned it. Have you guys ever heard that one?
Yeah.
Is that more common in
Yeah.
so whatever works for you, but the bottom line is this: when I have to divide a whole number by a fraction, my thinking is, well, first off, I got to make the whole number into a team player. I got to make him into 4/1. So that should always be your first thinking. And then copy dot flop, keep, change, flip, invert, and multiply. There's a ton of different ways to say it. At the end of the day, what it comes down to is this: you keep the first fraction the same, you change the division into a times, and you flip the second fraction over since the dawn of time. Got it? And then, of course, 4 times 2 is 8. 1 times 1 is 1, and 8 over 1 is 8. So it's a nice little trick for people to say what's 4 divided by a half. A lot of them will say 2. And it's not because you're trying to, make people feel dumb. It's just an interesting experiment. So, you have any questions about that? Okay, then let's get back to our graph now that we've done our basic skills review. So here it goes. Our happy vertex formula is negative b over 2a. And Cage, you started it for us. What is negative b going to be? And this is where, huh? It is. So this is where things can kind of go off the rails if we're not careful. So what we have to do right now is I'm going to draw a red little circle around it is 2a. And that's what the little mini lesson was for. So we have to do 2 times a, bless you, but a is a half, right? And so if you're a math person, you just know it's 1. But some people are like, I'm not buying. How is that 1? I don't get it. And some people can see the fishhook method. At the end of the day, what works for everybody on this planet is to take the 2, make 2 over 1, multiply it by 1 over 2, get 2 over 2. It's a lot of work, but it works. And you get 1. Good. So 2 over 1. That's our negative b over 2a is 2 over 1. And what's 2 over 1? Good job. So we can now say with confidence on our papers that the vertex of this parabola is at 2 comma, I don't know. And how do we find out what that is? Put it back in. So again, just take the business end of the equation and copy it down. 1/2 of parentheses squared minus 2 parentheses plus 1. And we're going to take the 2 and just pop it in. Boop, boop. What is the answer to the green box? It is. Love the good math. Love it. Square your 2 first, you get 4, and then you just say what's half of 4? Half times 4, half, however you want to say that. Nice job. Love the good math. 2. And then what's the answer to the purple egg? -4. And what's 2 minus 4? And what's -2 plus 1? We have a vertex. Got it? So step 1, let's all go together to the right 2, down 1, and make a vertex. So right 2, down 1, let's make a point. And again, I want to go off to the side, and you probably know where I'm headed with this, but the star on the stage here today is this number. What do you think he's going to do to all of my ups? He's going to times by a half, right? He's going to cut it in half. And so whatever I used to do, I'll do half as much. So again, for those of you kind of taking more thorough notes, just off to the side real quick, our normals, remember, are out 1, up 1, out 2, up 4, out 3, up 9, out 4, up 16, etc. But the half on your equation says, nope, I'm going to chop all of you in half. What's half of 1? 1/2. What's half of 4? What's half of 9? 4.5. What's half of 16? You will be able almost always to plot more points on these. I call these chonkers. These chonker graphs, as they get chonked out, they get fatter. Your north and south real estate runs out more slowly. You have more time to keep doing points. So you'll often, if not always, find that you can plot several more points on the chonker graphs than you can with the skinnies. All right, so let's get back to it. It is still pointing upwards. I'm going to zoom back in. And when I leave my vertex and I go out 1, how far up will I go? A half of a space right there. Right? We've seen these before. I call that a tweener. It's between 2 lattice lines. If I go out 2, how far up do I go? Would be four, but half of four is, so I go up two. And I moved this one down, I think, from earlier today, I think, because I want to be able to do more points. So let's keep going. Okay, I'm gonna have to probably zoom out here. Um, if I leave my vertex and I go out three, one, two, three, I'd normally go up nine. I'm gonna go up four and a half. One, two, three, four and a half. Get used to it. Okay, you're gonna have lots of graphing where you're kind of just chucking a point in between two lines. Do your best. If it's a third, go a little below a halfway. You'll see some of those. Let's keep going. If I go out four, normally I'd go up 16. What's half of 16? So I'm going to go up one, two, three, four, five, six, seven, eight. And I don't know if we'll have room for any more. I doubt it. But just in case, if we went out five, what would we normally go up? 25, because that's five squared. What's half of 25? And I don't think we quite have enough room for 12 and a half. Like you could probably get kind of close, but I think what we've done is we've maxed it out. And that's going to, if you take my algebra 2 class, it's just always going to be my rule. Algebra 1, algebra 2. All I ask of you is that you graph as many points as whatever piece of graph paper you're using will hold. And I believe we've maxed this one pretty much out. And so take a moment, sketch the graph. Remember, follow the rules. No horseshoeing back inwards. No arms, wings that go outwards. Try not to go vertical at any point, and don't forget your arrowheads. Any questions there? The third one's going to go really, really fast, and then the fourth one's going to be a little bit rougher. So let's get to the second page, the back page. You're not going to feel much stress about problem three at all. Let's blow through this. Let's see if we can get this one done in like 3 or 4 minutes. So what's A? What's B? Yeah, anytime there's not fractions involved, we're just always going to be quicker. So if our happy little vertex formula, remember, is always the opposite of V divided by 2A. What's the opposite of my B? And what's 2 times my A? And what's negative 24 divided by negative 8? Equals 3. So again, with confidence, we can all write down that, hey, I know where my vertex is. It is at 3 comma something. As has always been the case, we're going to plug that back in. So it's going to say negative 4 blank squared plus 24 blank minus 27. And if I put my cute little 3, what's the answer to this red box? Nice job. And again, that's when I know if someone says 144, I know I got to go talk to this kid. That's just order of operations 101. Good job, Gavin. So 3 squared is 9 first, and then you back multiply to get negative 36. What's 24 times 3? Again, lovely math. What's negative 36 plus 72? And what's 36 minus 27? 9 all day long. It's another change I made from earlier this morning. I moved this graph. I physically moved it. I made it go up higher so that we could graph a couple more points here. We ran out of real estate right away earlier today, so I wanted to get you a couple more. All right, let's go to the vertex, everybody. And to get to that vertex, we agree we all have to go right 3 and up 9. So way up here is our vertex. And why do I have so much room? Well, because it opens down. And if I throw the vertex up high and the graph opens down, that leaves us all of this land to plot points in, which is what I wanted to do. All right, so what do you think is going to happen when I stick the number negative 4 in front of my x squared? What does the negative do? Yeah, it turns it down. And after that, we don't have to talk about the negative anymore. Once you understand that the graph is going to go down like this, then we don't have to talk about the negative anymore. We just have to think about the number 4. What's the 4 going to do? Yes, whatever we would normally go down by, we just multiply it by 4. That's it. You got it. So I'm going to zoom back in again and let's go plot some points. So when we leave and go out 1, how far down will we go? 4, because our normal drop would be 1, but 1 times 4 is 1, 2, 3, 4. So our first 2 points, we got to go already way to the south. And this is where you see like the real power of adding a number in front. Normally, if I go out 2, how far down would I go? I'd normally go down 4, but what's 4 times 4? So we've got to go out 2, just a puny little out 2, and we're already going down 16. So that's 9 plus 7 puts us way down here. Whew. You have the same graph paper as I do, so we have enough room for these 5 points. Everybody see it?
I thought you took 9 times 4. Was it 3?
We didn't do that one yet. If I went out 3, if I had gone out 1, 2, 3, then that would be the one where I normally go down 9, and it would be 36. But we're still only on the one where we go out 2.
Well, I did the,
But no, you're right. If I did try to do out 3, I'd have to go down
I did
36.
4 times 4 instead of 4 times 4. So 8 instead of 15.
And again, try to graph that one. You'll see what I mean. Trying to get any sort of curvature out of super skinny parabolas. Oh boy, it's tough. Trying to make those look good. I don't care how long you've been doing this. It's not easy. You're not wrong about that. A little template where you can like squeeze it into place like a compass and tighten it down. That'd be amazing. You should make that. Invent that. What is it?
It's like,
Oh, really? I didn't give you one of these?
no, I was like, yeah, no, I should have figured that out myself. No.
Jeez Louise.
No.
Any questions on number 3? That was easy, right? Let's go do number 4. And I think now that you guys are rocking and rolling, 4 a half hour ago would have been rough. I think we're going to be okay. This one will be your least favorite of all because there's going to be some disagreeable fractions here. So that was on purpose. Okay, so what is my A value? Let's get started. -1/3. What is my B value? -2. I mean, one thing you can take to the bank, this is never going to change. Negative B over 2A. So what's negative B look like? 2 and over 2 times A. 2 times A, I'm going to write some stuff right here in this space, and then I'm going to come back and erase it, but I should show some work here. So 2 times A looks like this. 2 times A. Rough stuff here for some folks. What's rule number 1 when multiplying this? Rule number 1. Put 2 over 1. Thank you. If you do not have fractions, make fractions. That is job 1. All right. And now we're going to just use basic skills. It's a positive times a negative, so I know it equals a negative. And I'll just use red here. What's 2 times 1? 2. And what's 1 times 3? So as much as you may not like it, the bottom of our fraction is a fraction. When you do 2 times A, you actually get -2/3. This is not a finished product. The purple box is a work in progress. That's what negative B over 2A currently looks like, but it clearly needs some repairs. What's up, Jay Kirk?
The decimal at that point?
Nothing would be worse than using a decimal. Decimals don't use decimals. We'll just divide it out. Yeah. So what we're going to do now is we're going to take the purple box and we're actually going to just copy dot flop it out. And so what the purple box is it's really just a division problem, right? It's just 2 divided by -2/3. And again, I just have to ask, what's rule number 1? Like basic. What do I have to do? Make it a fraction, right? I hope that we're to the point where we don't ever not say that. Like we have to know that that's job 1 is make 2 into 2 over 1. And then the rule is copy dot flop, right? So the 2 over 1 stays. The division changes to times, and you flip the second fraction over to 3 over 2, -3 over 2. And so when you multiply it out, again, basic skills will never fail you. A positive times a negative is still a negative. 2 times 3 is still 6. 1 times 2 is still 2. And what's -6 over 2? Holy buckets. And that's just the work involved in finding the first half of the vertex. But what I can say right now, since that equals -3, is that my vertex is officially at -3, comma, I don't know. It's gnarly, huh? Let's go find the other half now. Let's take -1/3. By the way, the harder problems like this in the next homework assignment, you probably won't get to them until tomorrow, just if that makes you feel any better. The first page is kind of fluffy puffy, I think, compared to this. So we have negative 1/3 parentheses squared minus 2 parentheses plus 3. What's going in the parentheses? I know you can tell me this, so don't answer. Someone with a new voice, what is the answer to the green box? It's -3. Very good job. And how we get that, I know your calculator would give it to you, but I just, for those of you interested, you do this. You do the red jelly bean first. What's -3 squared? 9. What's a third of 9? 3. And then you put the negative on it because it was a negative times a positive. Solid play. And then how about this purple egg? What does he equal? +6. And then what's -3 plus 6? 3 plus 3. Not easy at all. Save the best for last there. But the rest of this is going to be a walk in the park because now all we have to do is go make the silly little graph. And so, again, I'm recording this so you could pause it or whatever, but I'm going to get rid of a bunch of the evidence now. I just want that. I want the vertex. And to get there, I go left 3 and I go up 6. So I'm going to go left 3, up 6, boom. Which way does this graph go? It goes down because of the negative. And what's going to happen to all of my down shots? They're going to be a third as big as they normally would be. Gnarly. I'm going to make you another little chart over here. You're welcome to copy this down. Normally, I would go out 1 and I would go down 1. Normally, I would go out 2 and I would go down 4. Normally, I would go out 3 and I would go down 9. Normally, I would go out 4 and I would go down 16. Normally, I would go out 5 and I would go down 25. Normally, I would go out 6 and I would go down 36. Like, you don't need me for that. I'm wasting your time there. Like, you know those numbers already. Those are just red list numbers. But we have to figure out what's a third of them because the number in front of x squared is 1/3. So I'm going to ask you some math questions. Here it comes. What's a third of 1? 1/3. What's a third of 4? 1 and 1/3. What's a third of 9? 3. What's a third of 16? 5 and 1/3. What's a third of 25? 8 and 1/3. What's a third of 36? 12. Again, your calculator can help you with some of that lifting. When I ask you for a third, you're really just going to type in divided by 3. Okay? That's what it means to take a third. All right, let's get back to it. Let's go finish our points. And so remember those numbers as I zoom in on this and we make some downward facing points. So here we go. When I go out 1, how far down do I go? A third, which I want to be aware that I don't want it to look like I went down halfway. I want to make it look like it's less than half because a third is, of course, less than half, right? And when I go out 2, how far down did we say we'll go? Go out 2, go down 1 and 1/3. Go out 3. What's a third of what the 9 would be? Out 3, down 3. By out 4, 1, 2, 3, 4, down. Anybody else actually write these numbers down other than me? We're going to go down 5 1/3. So we're going to go out 4, 1, 2, 3, 4, down 1, 2, 3, 4, 5 1/3 of the way. Anyone remember the next one? Out 5, 1, 2, 3, 4, 5, down 8 1/3. 1, 2, 3, 4, 5, 6, 7, 8 1/3. And I believe we can do one more. Heck, we might even be able to do a couple, but this ought to be enough. Out 6, down just a solid 12. This one's really convenient because the normal would be 36, but a third of that is very conveniently just a nice whole number 12. So out 6, 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're probably pretty maxed out there. So, and again, like I said, proof positive, when you have fractions, you can do a lot more points. I did not mean to gobble up that much time. I'm going to hand out assignment 57. Rest assured that tomorrow will be a work day. But let's work hard for 7 or 8 minutes, 9, whatever we have. And then just like I said, tomorrow, I promise I won't get in your way. We'll just work, work, work. Deal? Cool. And I'm going to leave the recording alive, but pause so that if anyone's like, hey, can we go over number 1 or whatever, then we will have time to do that together. The A value on number 1 is 2. Can we all agree?
Yeah.
And the B value is -20. Can we all agree?
Yeah.
And again, the formula that never changes is the opposite of B divided by double A. And so what is our opposite of B? 20. And what's our 2 times A? 4, and 20 divided by 4 is 5. So we can all rest fully assured that the vertex of this parabola will officially be at a point whose x-coordinate is 5. Then for the 30-second straight time, how do I find the y? You plug it back in. So I copy down this purple box, the business end of the function, and try to be meticulous about it. So it's 2 times blank squared. I'm just putting blanks wherever the x's used to be, minus 20 times blank, which I already put a 5 in there. That was my bad. And then that. Good. And then if I change this one into a 5, this is if 98% of my students answer this correctly, I will consider myself to be a failure. I need 100% of you to not answer the following question by saying 100. Don't say 100. What does the red box equal?
25. Oh,
50
yeah.
is correct. And if you said 25, I'm okay with that just because that means you weren't done. But again, you can see where 100 is going to keep me up at night because that means you're doing 2 times 5 too soon, right? So that's the one that red flags me. 25 just means you weren't quite done. So what I'm interested in is, can you do the 5 squared first, 25, and then back double it by the 2 and get 50? That's what's important, right? And then in the second part of this, you got the purple egg. What is that going to equal? Specifically minus 100. And then plus. And these numbers, they feel so big, but the computer isn't going to give you problems. I don't write these, okay? I cycle through and I pick them, but I don't write them. Like the computer writes them and then I pick the ones I like. So, I mean, the computer isn't going to lead you astray. It's very well programmed, this thing. And so the numbers may seem big, but at the end of the day, 50 minus 100 is -50, and -50 back up 48 is only -2. So like it all just kind of works itself out, right? Good.
Yeah, and then other points, we'll put it at 5, then -2.
So we're gonna all go right. If you guys could give me just another 30 seconds. I get that you want to pack, but just don't like be walking around because I got to get through this problem.
Go left 1 and then up 2. Isn't that 2?
Because it's a positive 2. Nice job.
And then
So
we go over 2, up 8.
good job. Nice
And
job,
that's
buddy.
all we can fit.
That's all we can fit.
Yeah.
Nice job. So if you got through number 1, good job. Again, tomorrow, nice full 45 minutes. Obviously, you're gonna have lots of questions, so plan on maybe wanting to go over some stuff or not. But this is what we're doing tomorrow. This assignment.